to gifted and science and technology class is our chemistry class. I'll be looking at redox reaction. That's oxidation reduction reaction. It's called redox reaction. Now let's look at the definitions of redox reaction. First, we are looking at in terms of oxygen. What is oxidation and reduction in terms of oxygen? Now, if you look at this reaction, carbon is existing alone, but on checking it out here, carbon has combined with oxygen. So I can call this oxidation. So what is oxidation in terms of oxygen? Is the addition of oxygen to a substance. That's oxidation. What about this? If you watch, there was oxygen here, but checking it out here, there is no more oxygen. So it means oxygen has been removed from zinc. It was combined to zinc. Now it has been removed from zinc. So this is called reduction. This is called reduction. So what's reduction in terms of oxygen? It is the removal of oxygen from a substance. What is oxidation in terms of oxygen? Is the addition of oxygen to a substance. Now let's look at number 2 in terms of hydrogen. What is oxidation in terms of hydrogen? And what is reduction in terms of hydrogen? Now look at this here. If you look at this from here, you see hydrogen and sulfur together. If you take it here, sulfur is now existing alone. Sulfur is existing alone. While if you look at this place, chlorine was just alone, and now chlorine is now added to oxygen. So now, what is oxidation? Oxidation is the removal of hydrogen from a substance. So check. In this case, hydrogen has been removed. So it means this is oxidation. Hydrogen has been removed. This is oxidation. While if you look at this place, hydrogen has been added. So this is now reduction. So it means that in terms of hydrogen, oxidation is the removal of hydrogen from a substance, while reduction is the addition of hydrogen to a substance. Now it means it's the opposite. In oxygen, we are adding, but in hydrogen is removing. That's the remover. That's what we call oxidation. Now let's look at in terms of electronegativity and electropositivity. Now we have this. Look at this. What's happening here is this is ion 3, ion becoming this. So this is ion 2 becoming ion 3. So what is occurring here is oxidation. Oxidation. But this is 0 becoming -3. So this is -3. 0 to -3, this is reduction. Now take note, I reiterate again. This element here is +2, while this is -2. So on addition of these two ion, we are having this to be ion 3. So ion is changing from +2 to +3. That's what ion is changing from. That's why we say oxidation. But if you look at this part, chlorine in its state here is 0, becoming -3, because this is +3. Ion is +3, chlorine is -3. So it means that this is what now? Reduction. 0 to -3 is reduction. Look at it this way again. Sodium from here to here. Sodium here is 0, but becoming here is now +1. So this is oxidation. Oxidation. Why this to this place, I have this as 0, then coming here is -1. This is reduction. So adding of electronegative element or electropositive element defines oxidation. So what is oxidation? Oxidation is the addition of electronegative element to a substance. Oxidation is the addition of electronegative element to a substance. What is reduction? The removal of electronegative element from a substance. That is oxidation and reduction. Now take note, I was also using oxidation number alongside. So if you see that plus 2 is changing to plus 3. So increase in oxidation number is also called oxidation. While here, this is 0 because an element in its free state has an oxidation number of 0. So 0 turning to minus 3 is reduction. So you see that a decrease in oxidation number is reduction, but an increase in oxidation number is called oxidation. So that can also be a term used in defining oxidation and reduction. Thank you. Now let's look at oxidation number. What is oxidation number? It is the electrical charge and atom of an element either in an uncombined or as an ion it carries. Now there are rules for calculating oxidation number. What's the first rule? We said that the oxidation number of an atom of an element in a free state or uncombined state equals 0. What does that mean? It means that if I have something like this, sodium, the oxidation number of sodium existing like this is 0. Oxidation number of sulfur is 0. Oxidation number of oxygen is 0. Oxidation number of potassium is 0. Once an atom is existing in a free state, even if it's a molecule, for instance, Cl2 is 0, O2 is 0. Once an atom of an element is existing in a free state or an uncombined state, just with itself or alone, we say that the oxidation number is equal to 0. Now look at number 2. It says the oxidation number of an atom of an element in the form of an ion equals the charge it carries. So if I have something like this, H plus, it means the oxidation number is equal to plus 1. If I have O2 minus, it means the oxidation number equals minus 2. If I have Al3 plus, it means oxidation number equals plus 3. If I have Cn minus, it means oxidation number equals minus 1. So once I have an ion, the oxidation number equals to the charge on the ion. What about this? Number 3, it says the oxidation number of the sum of atoms of elements that makes up a compound equals 0. Let's assume, look at this. This is H2O, water. What does that mean? He's trying to say that the sum of all the elements that makes up water, the oxidation number equals 0. So he's trying to say that 2H plus O is equal to 0. What is H? Now, hydrogen is not uncombined. It's not combining with oxygen. So what is the oxidation number of hydrogen? It's now 2 brackets 1. Hydrogen is 1 plus. What about oxygen? Oxygen is minus 2. We'll say equals 0. Now it becomes 2 minus 2 equals 0. So the oxidation number of compounds, so I can say CaCO3 equals 0. I can say H2SO4 equals 0. So the oxidation number of compounds is equal to 0. Take note of that. Now it means that calcium plus the oxidation number of calcium plus that of carbon plus that of oxygen times 3 will definitely be equal to 0. The oxidation number of hydrogen times 2 plus that of sulfur plus that of oxygen times 4 will equal to 0. Now, let's look at number 4. It says the oxidation number of the sum of atoms of element that makes up a radical equals the charge they carry. Look at something like this. I have OH minus. is saying that the oxidation number of oxygen plus oxidation number of hydrogen, everything equals -1. Look at another example. I have MnO4 minus. It's saying the oxidation number of manganese plus oxidation number of oxygen times 4, everything is equal to 0. So we are saying that the oxidation number of every radical, even if it's SO4 2 minus, everything, sorry, it's equal the charge it carries. So it equals -1, just as this equals -1. Then this is the charge it carries. So it means that the oxidation number of sulfur plus oxidation number of oxygen times 4, everything will equals -2. So when a radical is written, the oxidation, the sum of the atoms of the element that makes up the radical is always equal to the charge it carries. Now we'll be using all of these principles or all of these laws to now know how to calculate for oxidation number. Now let's look at some examples as regards in calculating for oxidation number in compounds. The first example 1 says, calculate the oxidation number of the underlying atom in the following. Now, question number 1, what is underlined? Question number 1, we underlining carbon in calcium tetrahydrocarbonate 4. So now it means that for number 1, how will I solve it? I know that the oxidation number of a compound equals 0. So I know that CaCO3 equals 0. The oxidation number of this compound equals 0. That's one of the rules. So it means that the oxidation number of calcium plus the oxidation number of carbon plus the oxidation number of oxygen times 3 equals 0. This will now be 2, that's plus 2. Oxidation number of calcium is plus 2, plus I'm looking for that of carbon. So carbon will remain as C, plus C, plus oxidation number of oxygen is now -2. Oxidation number of oxygen is -2 times 3, everything equals 0. So this will now be 2 plus C minus 6 equals 0. C will now be equal to 6, goes this way, becomes 6. This one comes this way, become -2. -2 equals 4. So the oxidation number of carbon in this compound equals 4. Let's see question number 2. It says the oxidation number of nitrogen in this compound, meaning I will say that I'm looking at PB, open bracket, NO3, close bracket 2. That's what I'm looking at. So now I will say the oxidation number of PB plus, now this 2 is affecting this N. So it will now be the oxidation number of 2 times N, then the oxidation number again, plus oxidation number of this 2, 3 is affecting this O, this 2 is affecting this O. So it will now become oxidation number of 6 bracket O, because 2 times 3 is 6. So now I put it as oxidation number of lead will now be 2, that's plus 2, plus oxidation number of nitrogen. Nitrogen can have 2 oxidation number. It's either it is 3 or it's 5. So now we'll be using for nitrogen. Okay, we are looking for nitrogen because nitrogen is what was underlined in our question. Nitrogen was underlined in our question. So I have it as 2N, oxidation number of 2N. So it will be that way. It will not be 2N plus. Now please follow me very well. To be 2N plus. What is the oxidation number of oxygen? It's -2. So plus 6 brackets minus 2. Everything equals 0 because the oxidation number of a compound equals 0. Look at it again. Oxidation number of lead plus oxidation number of nitrogen. That's 2 times nitrogen because these two is affecting this nitrogen. Then plus oxidation number of oxygen, 2 times 3 is 6. So it's now 6 times oxidation number of oxygen. So now I said this is plus 2. This is what we are looking for. So I retain as 2n, while this is minus 2 times 6. So it becomes what now? 2 plus 2n minus 12 equals 0. So what do we have now? This goes this way, this goes this way. I have 2n is equals to 12 minus 2. 2n is equal to 10. N is equal to 5. So the oxidation number of nitrogen in this compound is equal to 5. Take note of this. Let's see number 3. Question number 3 says oxidation number of X in H2SO4. So now I have H2SO4. What's the oxidation number? Sum of everything will equal to 0. So now how do I have it? 2H, 2H plus X. That's oxidation number of H plus oxidation number of sulfur. That's X plus oxidation number of 4 times O, everything equals 0. That's 4 times oxygen, everything equals 0. What is the oxidation number of hydrogen? Is plus 1. So it becomes 2 bracket plus 1 plus, what's the oxidation number of sulfur? Is minus 2, is 4, and is 6, depending on which of them we are dealing with. But remember, sulfur was underlined, so I'm looking for the oxidation number of sulfur. So it becomes oxidation number of sulfur plus, what is the oxidation number of oxygen? Is minus 2 times 4. So it's now 4 times minus 2. 4 times minus 2. That's what we have there. Everything will be equal to 0. So what do we now have now? We have here, I have 2 plus x plus, this is minus 8, bracket minus 8 equal to 0. What do we now have now? Let this becomes 2 plus x minus 8 equals 0. Minus 8 goes this way. I have 2 plus x equals 8. This goes this way. I have x equals 8 minus 2. The answer is 6. So the oxidation number of this compound, or sulfur in this compound, equals to 6. That's why it's called tetraoxosulfate 6-acid. Now let's see example 4. Example 4 is, that's number 4. We have CrO2O7 2 minus. We are looking for the oxidation number of chromium. Now this is 2 affecting chromium. It will be 2CrO plus, this is 7 affecting O. It will be 7O. Now everything will be equal to minus 2. That was the law for a radical. The oxidation number of the sum of atoms that makes up the radical equals the charge that it carries. Now it means I now have 2CrO plus 7 bracket minus 2. Oxidation number of oxygen is minus 2, is equal to minus 2. So I have 2CrO minus 14, then it's equal to minus 2. Now see what will happen here. If I now have 2CrO is equal to minus 2 plus 14, I have 2CrO is equal to 12. So CrO is now 12 over 2, which equals 6. Now the answer is 6. Now take note, oxidation number does not take what now? Does not take signs. But sorry, oxidation number takes signs, but valencies does not take signs. So actually what I have here is actually plus 6, not minus 6. Oxidation number takes signs, but valency does not take sign. If it was a valence number, I would just call it 6. Minus 1 in valency is called 1. Plus 1 in valency is called 1. But minus 1 in oxidation number is called minus 1. Plus 1 in oxidation number is called plus 1. So all these guys are very important. You know them. Now let's look at another question. The next question now is for number 5. Number 5 says Mn MnO4 minus. MnO4 minus, it means the oxidation number of manganese is what was underlined here. So oxidation number of manganese plus oxidation number of oxygen times 4. Everything is equal to minus 1. Why? the oxidation number of a radical equals the charge that it carries. So this will now be Mn plus oxygen. What's the oxidation number of oxygen? Is how many? Is minus 2 times 4. So it's equal to minus 1. So I have Mn minus 8 equals minus 1. So minus 8 go this way. I have Mn is equals to minus 1 plus 8 equals plus 7. So this is plus 7. Now let's see other examples as we keep going. We have xenon. Now we have XeO4. This is very funny. Why? Because I know that everything will be equal to 0. Now xenon is on the line, so it becomes xenon plus oxygen is minus 2. That's minus 2 plus, what about this? Fluorine is minus 1. So I have minus 1 times 4 equals 0. So xenon will now become minus 2 minus 4 equals 0. Minus 2 minus 4 equals 0. So xenon is now equal to, I have it as 2 plus 4, which equals 6. Now, not just 6, remember, it becomes plus 6. Always know that to oxidation number we add signs, but to valencies we do not add signs. So let's look at question number 7. Question number 7, we have Na2C2, then we have O4. Everything will be equal to 0. Oxidation number of a compound equal to 0. So what is the oxidation number of sodium? Is plus 1. Now it means that I have 1 times 2. That's for sodium. Remember, we are looking for that of carbon. It was stated in our question number 7. So now plus I have 2C, that's for carbon, then plus, what about this? Is now minus 2. Oxidation number for oxygen is minus 2. Minus 2 times 4. Everything becomes 0. Now I now have it as 2 plus 2C minus 8 equals 0. So I have it as 2C is equal to, let this become 8 minus 2. 2C equals 6. So therefore, we now have it as C is equal to 6 over 2, which equals plus 3. Now let's look at question number 8. Question number 8, we are looking at LiBH4 and boron is on the line. Now you see this that you want to solve. Lithium is plus 1 and you have 1 plus boron plus hydrogen. Now take note, if you take hydrogen as plus 1, you'll be having 1 times 4. Everything equals 0 because the sum of the oxidation number of a compound equals 0. Now you notice that here will now be 1 plus B plus 4 equals 0. If you solve, you now have boron will now be equal to, this goes this way, it becomes minus 4. This goes this way, it becomes minus 1. You now have boron to be equal to minus 5. This is not correct. You cannot solve the oxidation number of boron in this method. Why? Because the oxidation number of hydrogen in a mental hydride is minus 1. So the right way to solve this will be lithium, which is plus 1, 1 plus boron, which we are looking for, plus hydrogen is minus 1. So it's minus 1 minus 1 times 4 equals 0. I reiterate again, the oxidation number of hydrogen in a mental hydride is minus 1. So what we have now is 1 plus B minus 4 equals 0. Therefore, boron is equals 4 minus 1 equals plus 3. So this is now called lithium tetrahydrobromate 3. Thank you. Now let's see question number 9. Question number 9, we are looking at C6H12O6. Solution of this, remember we're looking at the underlying question here is carbon. So we are looking at oxidation number of carbon. So that means it will now be 6C plus, I have 12, 1, because oxidation number of hydrogen is 1, plus O, that's 6 bracket minus 2. That of oxygen is minus 2. Everything equals 0. So I will now be having 6C plus 12 minus 12 equals 0. Look at it again. 6C plus 12 minus 12 equals 0. Now I have 6C plus 12 minus 12 is 0. 6C is equal 0. So this will now be 0 over 6. So this equals 0. Please note this, that the oxidation number of the carbon in the glucose chain ranges from -1 to +1. But on the average, the oxidation number of the carbon atom or the carbon in glucose is 0. Take note of this. The answer is 0. Now let's look at question number 10. Question number 10 is the oxidation number of ion in this. I have Fe3O4, and this is underlined. Now, a normal chemist or a normal student will just go and say, okay, it becomes oxidation number of ion, that's 3F, plus oxygen is -2 times 4, everything is equal 0. Then the next thing is 3Fe minus this becomes 8 equals 0. So you now have 3Fe is equals 8. So Fe is now equals 8 over 3. That is not correct, because you will not have an oxidation number of ion to be in fraction. So what is the right way it ought to be solved? It means this compound is actually existing as this. Fe3O4 is a combination of FeO and Fe2O3. So it means that iron is existing in this compound in two different compounds. So I have it here and I have it here. So it's a combination of these two that gives us this. Now the question is now, what is the oxidation number of iron here and the oxidation number of iron here? That's what I will give to the ion in this compound. So now for FeO, it will be given as oxidation number of ion, which is Fe, plus oxidation number of oxygen, which is -2, equals 0. So Fe is now Fe minus 2 equals 0. Fe equals +2. So the oxidation number of ion in this is 2. So this ion 2 oxide. Now, what about in this compound? The oxidation number of ion in Fe2O3. Now, I'm underlining ion. It will now be 2Fe plus oxidation number of oxygen times 3. That's 3 times -2 equals 0. So this becomes 2Fe plus bracket -6 equals 0. So I have it as 2Fe minus 6 equals 0. So I have 2Fe is equal to 6. So Fe is equal to 6 over 2, which is equals +3. So it means that in this compound, ion is +2. In this compound, ion is +3. So this is ion 3 oxide, this is ion 2 oxide. So ion 3 oxide combining with ion 2 oxide gives us this. So now what is now the oxidation number of ion in this compound? It means ion is +2 and ion is +3. So we call this compound ion 2 diion 3 oxide. We call it ion 2 diion 3 oxide. Thank you. Now let's look at question number 11. Number 11, we have NH4NO3. Now, we are looking for the oxidation number of nitrogen in this compound. So now, nitrogen. That's what we are looking for in this compound. So how can this be done? I will split the compound into its ion. I will have NH4 plus NO3 minus. So now it means the oxidation number of nitrogen in this compound will be 2. That's two different figures. So now I want to solve out this first. So for NH4 plus, I will have it as oxidation number of nitrogen plus that of hydrogen times 4 is equal to plus 1, is equal to plus 1. Take note of that, is equal to plus 1 because the oxidation number of a radical equals the charge that it carries. But for the second one, which is now NO3 minus, it will be oxidation number of nitrogen plus that of oxygen times 3. Everything is equal to minus 1. It's equal the charge it carries. Now this will now be nitrogen plus this plus 1 is equal to 1. So I have nitrogen is now equal to, now I have this as 1 minus 4. And I have this as equal to minus 3. I have this as minus 3. What about here? I have it as n plus 3 bracket minus 2 is equal to minus 1. So n minus 6 is equal to minus 1. N is now equal to minus 1 plus 6. N is equal to plus 5. Now it means that the oxidation number of nitrogen in this compound is equal to plus 5 and minus 3. Thank you. Now I want you to do question number 12 yourself by looking for the oxidation number of chlorine in this compound, this bleaching powder. I want you to look for the oxidation number of chlorine here. And mind you, to solve this, you still have to split the compound just the way I did here. Thank you. Now let's look at example 2. Example 2 is a find the value of y in the following equation. We're looking for the value of y in the following equation. Now, I want you to see something very good in example 1. There is water in here. So it means solution 1. I have aluminium plus 6 bracket H2O. Everything is equal to y. I hope you know that the sum of all the oxidation number of the atoms that makes up a radical equals the charge that it carries. So everything equals to y. This is not equal to 0, it's equal to y. Now, what is the oxidation number of aluminium? Is plus 3. That's the oxidation number of aluminium. Plus, what about this? It is 6 open bracket 0. Why 0? The oxidation number of a compound is equal to 0. No need of stressing yourself, just drop it there at 0. So now everything equal to y. So I have plus 3 plus 0 is equal to y. Therefore, y equals plus 3. So the value for y here in this compound equals plus 3. Now let's look at this again. Example 2. To check this, now this is zinc plus this is cyanide. The cyanide, you have it as 6 bracket Cn. Everything is equal to y. Now, will this be 0? No. Cyanide is not a compound, it's a ligand, a highly electronegative ligand. So it is now plus 3, that's for zinc, plus 6 bracket minus 1. The oxidation number of cyanide is minus 1. This is not a compound. So we say it's equal to y. Therefore, plus 3 minus 6 is equal to y. Plus 2. Zinc is plus 2, not plus 3. So zinc is plus 2 minus 6 equal to y. Therefore, minus 4 equals y. Y equals minus 4. So it's necessary, you know, that what y is equal to in this compound is minus 4. But in this expression, is plus 3. Take two. Now we'll be looking at change in oxidation number. We just looked previously at how to calculate oxidation number. Now let's see how this applies to equations. So what is the change in oxidation number of iodine ion in the reaction? Now, mind you, change in oxidation number equals the oxidation number, the oxidation number of the product minus the oxidation number of the reactant. This is what we use to calculate for change in oxidation number. So now let's come over here. What do we have here? We have the iodine ion here. Iodine ion is now becoming this. So if you check, it's changing from -1. Look at it here. From -1. So it's changing from -1 to 0. That's the change. Why? Because the oxidation number of an atom of an element in the form of an ion equals the charge it carries. So it's carrying a -1, so the oxidation number is -1. Now it's changing. Now I will not stop here because this is still a reactant. So it's changing to the product. Look at the product. It's existing as iodine molecule. So in a free state, the oxidation number of an atom of an element equal to 0. So it's changing from -1 to 0. Now, this is showing increase in oxidation number. So this is oxidation. Increase in oxidation number is oxidation. And the substance that is undergoing oxidation is actually called the reducing agent. So that is as regards oxidizing agent and reducing agent. So now it means that the change is from -1 to 0. So if I come over here, it means the product is 0 minus, what is the oxidation number of the reactant? -1. -1. So my answer is +1. So the +1 is showing that it's an increase in oxidation number, hence it's called oxidation. Now let's look at number 2. Number 2 says the change in the oxidation state of ion in the reaction is dash. Now where is ion changing from? Ion is changing from here down to here. That's what ion is changing from. Now the question is now, what is the oxidation state of ion here? Now remember, the oxidation number of a compound is equal to 0. This is a compound. It has no charge on top. So the oxidation number of a compound equals 0. So if I'm doing for ion, I will simply say Fe. Now ignore this. Ignore this coefficient, Fe plus chlorine is -1 times 3. Everything will be equal to 0. So I have Fe minus 3 equals 0. Therefore, Fe equals +3. So it means ion is changing from +3. Ion is changing from +3 to, if you come over here and do the same, you realize that ion is +2 because I will be having Fe plus -1 times 2 because chlorine is -1 times 2 is equal to 0. So if I solve this, Fe will be equal to +2. So ion is changing from +3 to +2. That's what ion is changing from. So if you look at this already decreasing. So it's a reduction reaction. This is reduction. Remember, the substance undergoing reduction is an oxidizing agent. The substance undergoing reduction is an oxidizing agent, while the one undergoing oxidation is a reducing agent. So what is now the change? This for number 1. What is now the change? So I have change in oxidation number is equal to the product is +2, so it becomes +2 minus, what is the reactant? +3. minus, I have it as plus 3. So this will now be equal to 2 minus 3 equals minus 1. Now, the minus sign is showing us that there's a decrease. So hence, it is a reduction reaction. Let's look at question number 3. Question number 3 is saying the change in the oxidation number of oxygen in the above reaction is dash. Now, what is oxygen here? And what is oxygen here? That's just our question. Now, mind you, oxygen here is minus 2. Oxygen in water is also minus 2. Now, I would like to show you that very fast. I have it as CrO2O72 minus. That means CrO2 chromium, the oxidation number of chromium. Remember, we have solved this before, it's plus 6. So it will be 2 bracket 6 plus oxygen now is now 7 bracket O is equal to minus 2. Now I'm looking for the oxidation number of oxygen. So it becomes 2 times 6 is now 12 plus 7O is equals minus 2. So if if this goes this way, I will have it as 7 bracket O is equals minus 2 minus 12. So I have 7 bracket O is equal to minus 14. Therefore, O as oxygen is equal to minus 14 over 7 equals minus 2. So it means the oxidation number of oxygen in this is minus 2. What about in water? What about in water? Let's do it here. What about in water? Water is H2O. So it means the oxidation number of everything will be equal to 0. So I have 2 bracket H plus O is equal to 0. What's the oxidation number of hydrogen? Is 1. So it's 2 bracket 1 plus O is equal to 0. So if I take this way, I will have oxygen is equal to minus 2. So the oxidation number of oxygen in this place is minus 2. Also here is minus 2. So if I now have the oxidation number in the product as minus 2 and in the reactant as minus 2, what would that be? My change in oxidation number is equal to oxidation number in the product, which is now minus 2, minus open bracket. What is the oxidation number in the reactant? It's still minus 2. That's here, minus 2. So I'll be having minus 2 plus 2. What becomes my answer is 0. So the change in the oxidation number is what now? Is 0. So we are trying to say that there is neither a reduction nor an oxidation occurring in what now? In oxygen. Thank you. Now let's now see how we balance half cell reactions in acidic medium. But before then, I want you to take note of these exemptions. Very, very important, because when we're solving questions in uh, oxidation number, we made use of them. Was that oxidation number of hydrogen in mental hydride is minus 1. Oxidation number of oxygen in peroxides is minus 1, but in superoxides is minus half. Then we have, for compounds with fluorine, the oxidation number of oxygen is plus 2. Please take note of this. They are very important. Now we're looking at how to balance a half cell reaction in acidic medium. Now, how do you balance such a reaction? Now, if you look at this reaction, you see manganese and oxygen together as a radical. But over here, you have just manganese as an ion. So it means there is something I have here that I don't have here. And what is it? It's oxygen. So I'm looking for a way to introduce oxygen into this side of the reaction. So the only way I can bring in oxygen is to add water. So the first thing I will do to this reaction, I will say add water, add water, add water. Add water to which side? To the right hand side. Now, if it was this side, I have a deficit of oxygen, I will always add water to my left hand side. So it's not a compulsory phenomenon that I will always add water to my right hand side. So where I always add water to is the side with a lesser amount of oxygen. So I can only bring in oxygen by adding water. So now in adding water, I'll be having MnO4 minus. Now remember, is to give me here Mn2 plus H2O. Now I have 4 oxygen here, so to equate it on this side, I will add 4 molecules of water. So haven't introduced water here, I also have added hydrogen here. So how will I balance the hydrogen on this side? So I have to now ask 2 times 4 is 8. So I'll bring in plus 8 ion here, 8 hydrogen ion. So if you watch out now, we have balanced N, manganese, manganese. We have checked on oxygen 4. We have checked on oxygen 4. We have checked on hydrogen 8. 2 times 4, hydrogen 8. But there is one thing left that is not balanced yet. What is that one thing? Well, let's check it out. What is the total number of the oxidation number of this radical? Remember, the oxidation number of a compound, of a radical or an ion equals the charge that it carries. So the oxidation number of everything here is equal to -1. What about the oxidation number of everything here? It will also be -1, but times this coefficient here, that becomes +8. What is the oxidation number of everything here? It's +2. And what is the oxidation number of everything here? Is 0. The oxidation number of a compound equals 0. Now, if you take the sum of the charges on my left hand side and on my right hand side, you realize that I have here -1 plus 8. That will give me +7. So I'm having +7 as the total charge at my reactant side, while here I'm having +2 plus 0. So I'm having +2 at this side. Now take note of this, very important, +2 plus 7. So now you realize that both sides does not have the same number of charges. There is an increase in the charge number at the reactant side more than that of the product side. So what will I do to balance the charge? I have to introduce electrons. Addition of electron is a reduction reaction. So adding an electron to this shows that this reaction is a reduction reaction. So now, how many electrons will I add to 7 to make it equal to 2? How many negative particles will I add to 7 positive particles to make it equal to 2? I will add 5 electrons. So I will add 5 electrons to this place to make it, so I'll put it as plus 5 electrons. So my equation will now be MnO4 minus plus 8H plus 5E minus to give us Mn2 plus 4H2O. So this reaction is balanced. Thank you. Now let's look at another question here. Now, if you look at this, I have CrO2O72 minus is giving me CrO3 plus. Now, what about this? You realize that to balance this first, the number of chromium here is 2, but the number of chromium here is 1. So the first thing I will do is to add 2 here to balance chromium. I will not add 2 here. No, it's to add 2 here to balance chromium. Now, if chromium is not balanced, what's the next thing? There is oxygen here. There is no oxygen here. How will I bring in oxygen? In this side is to add water. So I will come and I will have CrO2O72 minus is giving us 2CrO3 plus H2O. Now, how many molecules of water will I add? Is depending on the number of oxygen I have here. So I have 7, so therefore I'll be adding 7H2O. Now, water has introduced hydrogen into the compound or into the reaction. Hence, 2 times 7 is 14. So I'll come here and add plus 14 H plus. So I have now balanced my hydrogen on both sides. Now, what is now the only problem? Now, the problem or the challenge now is, let's see the total number of charges at our reactant side and also at our product side. So it means for this, everything equals -2. So I have -2 on this side, plus 1 times 14 is plus 14. Then what about this side? I have plus 3 times 2, which is now plus 6. Then why water, the oxidation number of water is 0. 7 times 0 is 0. So on the reactant side, my total number of charge is -2 plus 14. That is now plus 12. So I have plus 12 on my reactant side. What about on my product side? I have plus 6 plus 0. That is now plus 6. So now if you see this as this, you now ask yourself, are the questions, are the charges balanced? No, they are not balanced. So which one is bigger? 12 is bigger. If you remember one of our classes, we said always add electrons to the side with a higher charge. So to make 12 equal 6, I will be adding 6 electrons to reduce 12 to equal 6. So it means they are all balanced in their atoms and also in their number of charges. So therefore, it will now be plus 6 electrons. So that becomes CrO2 O7 2 minus plus 14H plus 6E minus to give us 2CrO3 plus 7H2O. That means the equation is balanced. Now let's look at this question. This is a very important question set by examination bodies. It says, find the value of X, Y, and Q in the half cell reaction in acidic medium. Now, take note of this. The problem with this question is you try to check X is here at the reactant, X is here at the product, meaning X is balanced. Now, the next thing is I have O here, 4. Oxygen is 4. Oxygen here is just this I know. I don't know what is here. So to make oxygen balance here, it means that I have to make Q to be equal to 4. So oxygen is now 4. Now, if oxygen is 4, that means 2 times 4 is 8. For hydrogen, it means Y is 8. So my hydrogen is balanced, just as my oxygen is balanced. Now, the question now is, what will now be the number of electrons? So I will write my equations now as this O4 minus, there's a minus sign here, plus is now 8H plus Ne minus to give us H2 plus I now have 4H2O. Remember my Q is 4. Total number of charge here is -1. Total number of charge here is plus 8. I don't know the total number of electrons here, but total number of charge here is plus 2 and everything here is 0. -1 plus 8 is plus 7 plus 0 plus 2 plus 0 is plus 2. So I have 7 plus 7 here. I have plus 2 here. Plus 7 is greater than plus 2. How many electrons will I add to plus 7 to make it equal to plus 2? Is 5 electrons. So it means that my N is equal to 5. So I can now boldly say that my Y is equal to 8. My N is equal to 5 and my Q is equal to 4. That becomes the answers to this. Thank you. Now let's look at this example. Balance the equation in acidic medium. Now, this one looks more critical than the ones we've been doing before. What is about this? You realize that ion is changing from +2 to +3. Ion is changing from +2 2 plus 3, meaning iron is undergoing oxidation. This is oxidation. Now, what about chromium? Chromium is changing from here to here. That's what chromium is changing. Now, what is chromium changing from? Chromium is changing from, remember, chromium here is plus 6. So it's changing from plus 6 to plus 3. That is reduction. So it means that one of these species is undergoing oxidation while the other is undergoing reduction. So what we'll do is we'll split the equation into two and solve for oxidation separately and balance reduction separately. Then we'll now combine both of them at the latter end. So now let's move for oxidation. For oxidation, reaction, I have Fe2 plus becoming Fe3 plus. That's what we have in oxidation. Now, if this is what we have in oxidation, how will I balance this? This guy has a total charge of plus 2, while this has a total charge of plus 3. What will I do to balance the charges? I will add electrons to the side with a higher charge, meaning I will add plus 1 electron. That's plus 1 E minus. So in adding 1 electron here, it has balanced this side up because this is not 3 plus times minus is minus. So it's 3 minus 1, which is now 2. So it's equal to this other side. So we have balanced the oxidation reaction. What about the reduction reaction? Reduction reaction. Reduction reaction. What about it? Reduction reaction is CrO2O7, 2 minus, there's a 2 minus here, 2 minus, it's giving us, what's it giving us? It's giving us 2CrO3 plus. Now remember, how did we balance this? In our previous example, we said there is oxygen here and there is no oxygen here. So we now said bring oxygen to this side by adding water. So plus H2O. How many molecules of water will I add? I will add the molecule of water depending on my oxygen. My oxygen here is 7, 2 times 7, sorry, 7 here. So to balance it up here, I will add 7 here so that my oxygen can also be 7. 2 times 7 is 14. So I will balance my hydrogen this way because of the hydrogen that is not here. So I will put plus 14 hydrogen ion. So now this is what we have arrived at. But remember, this is still not balanced. Why? Because the total charge at my left hand side is not equal to that in my right hand side. So if I bring my reaction here as CrO2O7, 2 minus plus 14H plus to give us 2CrO3 plus 7H2O. Now, what will I do here? Remember we said that everything here is minus 2, everything here is plus 14, everything here is 2 times 3 is plus 6, while everything here is 0. So, on checking out for our charge, minus 2 plus 14 is now plus 12. Plus 12 plus 6 plus 0 is 0. Sorry, is plus 6. So this is plus 6. So to balance 12, to make 12 equals 6, we said add 6 electrons. So I will add 6 electrons. It will now become CrO2O7 2 minus plus 14H plus 6 electrons to give us 2CrO3 plus 7H2O. Now this is balanced. Now what is this concerning the reaction? Now remember, recall. What do I want you to recall? Equation 1 is Fe2 plus to give us Fe3 plus E minus. This is my equation 1. What about my equation 2? Now, equation 2 is now CrO2O7 2 minus plus 14H plus 6E minus to give us 2Cr3 plus 7H2O. So this is our equation 2. Now, if you look at equation 1 and equation 2, there is something that is common but is not equal. What are those things? I have electron here as 1 and I have electron here as 6. So these electrons are not equal. They are not balanced in their magnitude. So what will I do? I will say multiply equation 1 by 6. So 6 will times everything through so that the electrons can be equal for me to not be able to cancel that. Multiply equation 1 by 6 and equation 2 by 1. So since I have one electron here, I will use 1 to multiply everything in equation 2, and I will use 6 in equation 2 to multiply everything in equation 1. So what will I now have? I will now have 6 times everything here will be 6Fe2 plus to give us 6Fe3 plus 6 electrons. What about everything here? I will use 1 to times everything here. I will now have just the same thing because nothing will change because I'm multiplying by 1 plus 14H plus 6E minus to give us 2Cr3 plus 7H2O. Now, since I have everything like this, I will add up equation 1 and 2 together. I will add up equation 1 and 2 together. So I will take everything at the reactant side together and everything at the product side together. So what are we going to be having? We will now be having 6Fe2 plus, now I will now come over here to add plus CrO2O7 2 minus plus 14H plus 6 electron. Now I am now here. Now I'll say to give us, I'll come back here now and add all the product together to give us 6Fe3 plus 3 plus 6 electron plus 2Cr3 plus 7H2O. Now, if you check on the reactant side, I have 6 electrons. If you check on the product side, I have 6 electrons. So 6 electron cancels out 6 electron. Then the final balance reaction will be everything you have there in the reaction.